Okay, so we are looking at the assignment that you guys had yesterday, and that was the one that we looked at for solving the side of a right triangle using trig. Now we're not using, we're going to use the regular trig functions, but remember trig's basically a relationship between the angles and the ratios of particular sides in a right triangle. So with this particular one here, we're looking at solving right triangles. So if I'm looking at number 1, this is on your assignment. We have the angle that's 72 degrees, and then we've got the x and the 6. Now, what I always like for you to do is to look at the angles. The angle we're looking at is this one right here. So based on that, I'm going to label the other sides of the triangle. In fact, I'm going to zoom in a little bit, and we'll do this. Making you dizzy here. Okay, so this is the angle. Now, in trig, like I said, it's a relationship between the angle and the ratios of particular sides depending on the function you're using, okay? So we're going to pick the function that we're going to use based on the sides we're provided. Well, if you look at this triangle, I'm provided this angle. That means that this is the adjacent side. This is always the hypotenuse because it's across from the 90-degree angle. And that makes this the opposite side. So what I'm going to do is I'm going to look at these three and determine which two I'm going to be using. Well, which two am I provided? I'm provided hypotenuse and I've provided adjacent. Okay? So if you remember SOHCAHTOA, we're looking at adjacent and hypotenuse, which would be cosine. So I know that the cosine of 72 degrees is going to equal 6, which is your adjacent side, over x, which is your hypotenuse. Okay? So I'm looking at this ratio now, and then all I need to do is I'm going to have to kind of solve this using cross multiplication. Now remember, when we set up any number or any value, in order for it to maintain its value, we can always put it over 1. So I'm going to put cosine 72 over 1. Call it cosine. Don't call it cos or cos. It's cosine. It's short for cosine. It's just an abbreviation for the function. So now I'm going to cross multiply. What's 6 times 1? 6. Now I'm actually going to do the cosine here of 72. And when you do the cosine of 72, I'm getting into my calculator here, you can either cross multiply and make the, I'm looking for my calculator here. Hopefully it's scientific, and it's not. When I cross multiply, I'm actually going to do the 6 times 1 and the cosine 72 times the x. Now there's two ways we look at this, like I was mumbling, because I'm just distracted. Cosine of 72 times x, we can actually cross multiply here, and we can write this as x times cosine 72. Okay? And so then what would we do? We would actually divide both sides by cosine 72. Okay? So you've got to make sure, first of all, that your calculator is in degree mode. Okay? So when I do cosine of 72, I actually get 0.3090. So that's 0.3, oops, let's try this again, 0.3090. So I've got 6 equals 0.30, cannot write tonight, 3090 times x, right? Because cosine 72 is 0.3090. So I'm going to then solve for x like I would do in any other equation. I'm going to divide both sides by the coefficient, 3090. Hey, I wrote it right this time. So 0.3090. And when I do the division, I'm going to divide the 6 by 0.3090. And when you do that, you get 19.42. and we're going to round to the nearest tenth, so it's going to be 19.4. And that's going to be the length of the hypotenuse. So the hypotenuse is 19.4. Okay? That's the length of the adjacent side. So if we wanted to find the opposite side, we could then do the opposite over adjacent, and we could do a trig function again, or we could do Pythagorean theorem. We're not going to do that now. We're just looking at finding the missing sides right now, just the ones that are indicated. So let's do a little bit better example. Let's do number 3. Number 3, your angle is right here. That's 24. So let's label. That means this is the adjacent side. This is the opposite side. And this is the hypotenuse. So what I'm going to do is I'm going to look at this and decide which one I'm going to use, which function. Well, I'm provided the opposite and the adjacent. And which function is opposite over adjacent? Tangent. So the tangent of 24 degrees equals the opposite, which is x, over the adjacent, which is 12. Because from 24, x is the opposite, 12 is the adjacent. Remember, tangent is a function that asks you, given this angle, what's the ratio of the opposite and adjacent sides? Okay, so I'm trying to adjust this here a little bit. There we go. So I'm going to actually set it up the way I did a while ago. So I'm going to put this over 1 because I can. And then from there, I'm going to cross multiply. So this is x, because x times 1 is x. And then I'm going to actually convert the tangent 24 this time into a decimal before I cross multiply. And this becomes 0.4452. So I'm going to be cross multiplying 12 times 0.4452. And when I multiply 12 times 0.4452, I get 5.34 or 5.3. Okay? And I always carry this out. I always carry this out to the 4th decimal place because I want to be as accurate as possible with the function. So that means that the opposite side is 5.3. If you want to be exactly accurate, this was the answer up here. If you want to be exactly accurate, then you'll actually type into the calculator 12 times tangent 24. That will give you the exact answer, but this will get you close. If you go out to 4 decimal places, you're going to be pretty darn close, rounding to the nearest tenth. And that's your significant figures. Okay, so let's look at the next one. Let's see if we can still fit on camera. We'll look at number 5. Number 5, actually, number 5 is another tangent. So let's skip down here to number 6. Okay, I'm going to skip down here to number 6. So on number 6, my angle of 63 is right there. So what that means is now this is adjacent, and let me get a pen that actually works because, you know, that wouldn't make too much sense to have something that you could see. This is adjacent, as you hear the printer going in the background. This is opposite, and this is always the hypotenuse, of course. So you have to look at what you're given to decide which function. Well, what values am I given? I'm given opposite and hypotenuse. Which function is opposite and hypotenuse? And that's sine. So we're going to say that the sine of 63 degrees, which is your angle, is equal to the ratio 16, your opposite, divided by x, which is your hypotenuse. So now from this point, I'm going to do the same thing. I'm going to put this over 1. I'm going to cross multiply. 16 times 1 is 16. And then I'm going to cross multiply this. I'm actually going to do sine of 63 and get an answer is 0.8910. And remember, I like to go to 4 decimal places just to be as accurate as possible. That's as close as we can probably get without having to write a bunch, without actually plugging this into the calculator. So I'm going to cross multiply here. 0.8910 times x is just 0.8910. Then of course our final step is going to be to divide just like any other algebraic question. So 0.8910. So when I do 16 divided by 0.8910, I get 17.95. Now 17.95, we're rounding to the nearest tenth. If it's actually, it comes out to 17.96. But if I'm rounding to the nearest tenth, what happens? That rolls up to 0. That would actually be 18.0. Because you have to keep that tenths place right there. Okay? So you can see that. So we have to round up. We can't keep the 9 there because it's 6. We have to round up to the next number, so that pushes this to 18. So that means that your hypotenuse is 18.0. And that's your hypotenuse rounded to the nearest tenth. And that is how you solve the right triangles when you're given one of the sides and you're given the angle that it corresponds to. You're actually able to find the other piece of that ratio.